Next is Z transformation. So we'll see the definition. So if a function f of n is defined for n is equal to 0, 1, 2, etc., and f of n equal to 0, for n less than 0, then f of 0, f of 1, f of 2 is a sequence denoted by sequence of f of n. The Z transform of the sequence f of n is defined as f of z is equal to z of f of n is equal to summation n is equal to 0 to infinite f of n z power minus n if the series converges. Series means summation, that is f of 0 z power minus 0 plus f of 1 z power minus 1 plus f of 2 z power minus 2. This is called a series. Converges means is when n tends to infinite, it will move towards a particular point, particular region, right, towards a point, then that is called converges. If the series is converges, then only you can apply Z transformation of that function. So where Z is a complex number, it contains the real part and imaginary part. This is called one-sided or unilateral. Unilateral or one side means it is applied for only the positive terms. See, summation n is equal to 0 to infinite positive terms. So if it is a negative, including negative terms, that is n is equal to minus infinite to plus infinite, then it is called bilateral or two-sided, right? Is a transformation, right? That is next one, two-sided bilateral is a transformation. So n takes the value positive and negative values. So f of z is equal to n is equal to minus infinite to plus infinite f of n z power minus n. This is called two-sided. If f is a continuous, f of t is a continuous function defined for the sampled values t is equal to n into capital T, n takes the value 0, 1, 2, etc., then the Z transformation f of t is defined as f of z is equal to z of f of nt, which is equal to summation n is equal to 0 to infinite f of n capital T z power minus n. We are replacing t, small t, by n into capital T. Region of convergence means, I told you already that, right? Convergence means it will move towards a point when n tends to infinite. The region where the point is occurring or lying, that region is called region of convergence. The value of z for which Z transform converges is called region of convergence. And we know the results: 1 minus x power minus 1, 1 plus x square plus etc., 1 plus x power minus 1, 1 minus minus plus will change here, right? 1 minus x plus x square. Similarly, 1 minus x power minus 2, 1 plus 2x plus 3x square plus etc., 1 plus x power minus 2, 1 minus 2x plus 3x square, e power I theta demorius thetam cos theta plus I sin theta, e power x expansion 1 plus x square by factorial 2 plus etc. n factorial we know, n into n minus 1 into etc., 2 into 1. 0 factorial 1, factorial 1 is also 1. And log 1 plus x, we know x minus x square by 2 plus or minus, right? X cube by 3 minus x power 4. Log 1 minus x, all are minus x minus x square by 2 minus x cube by 3 plus etc., Geometric progression, if we can consider the geometric series 1 plus r square plus r power n minus 1, n terms. From 1 to r power n minus 1, there are n terms. So it is 1 minus r power n by 1 minus r if r is less than 1. Otherwise, r power is 1 minus r, right? According for n terms, 1 n, then the formula become 1 minus r power n plus 1 by plus 1 minus 1 by r is less than 1 or greater. Infinite numbers, 1 plus r plus etc., up to infinite. We know 1 by 1 minus r or r minus 1. Suppose if you have first term a plus ar square etc., you have to multiply the summation with a into 1 minus r power n by 1 minus r according to that. These are all the basic results, familiar results. Linearity property. Linear means we know is it like a straight line. Ax plus by, ax plus b, cx plus d, 2x plus 1, these are all the linear because the degree of the equation is 1. If it is suppose if you are having ax plus by plus cz, all degree xy z variable degree is 1. So these are all the linear. So z transformation satisfy the linearity property. Linearity property means suppose f is a function, then f of ax plus by, which is equal to a into f of x plus b into f of y. Then this is called f satisfies the linearity property. Similarly, z is also a linear transformation because z of, there are two, if you are taking two functions fn and gn, a and b are constant, z of a into fn plus b into gn, which is equal to a into z f of n plus b into z g of n. So we'll see some basic results for the elementary function z transform. These are all going to be a formulas, right? We are keeping as a formulas. So we'll see. First to prove that z of k is a constant. So z of k, which is equal to k z by z minus 1. K is a constant. We'll see the proof. And also another condition, modulus z is greater than 1. That is also there. Given we are taking k as a function, so we'll take it f of n, which is equal to k. We know the formula z of f of n, which is equal to summation n is equal to 0 to infinite f of n z power minus n. So z of k, which is equal to replacing fn by k. So k into z power minus n. So k is common term. So take it outside from the summation. So k into, so z power minus n can be written as 1 by z power n. A power minus 1 is equal to 1 by a. Same. So expanding this, k into 1 plus 1 by z, we are putting n is equal to 0, 1, 2, 3, etc., etc. You will get 1 by z square plus etc., etc. This is same like 1 plus x square plus x cube. The formula is, we know 1 minus x power minus 1. Instead of x, you are having 1 by z. So we will get k into 1 minus x, 1 by z power minus 1. So taking LCM, z minus 1 by z. And also the condition is mod z greater than 1. That means 1 by mod z is less than 1. That is modulus of 1 by z is less than 1. Right? Now, so taking LCM, z minus 1 by z power minus 1. If a by b whole power minus 1 can be written as b by a. It's reciprocal. Here its reciprocal is k into z by z minus 1. So finally z of k is equal to k z by z minus 1. So if you want to find z of 2, constant number, right? Z of 2 or z of 3, then answer is 2 into z by z minus 1, 3 into z by z minus 1 directly. So take it as a formula, right? Thanks. We'll see you in the next video.